Hello, class. Today we're going to talk about getting the inverse of a function. Again, today we are going to talk about getting the inverse of a function. There's a pointwise discussion and there can be another geometric discussion. One thing I want you to know that we are only going to be getting the inverse of one-to-one functions. And of course, if you remember the horizontal line test, you know what I mean by one-to-one. If x is different from x1 is different from x2, then the output values will have to be different in a one-to-one function. And there is something called a horizontal line test. One example that is not one-to-one is the y equal x squared curve, where it's concave up in the first and second quadrant. And if you do the horizontal line test and draw any arbitrary horizontal line, the line will cross 2 times. And that means it is not a one-to-one function. So therefore, it does not have an inverse function. One thing we can say, if we have a discrete finite function with maybe just 3 ordered pairs, 1, 1, 2, 2, 3, 3, I made it very easy because the inverse of that would be 1, 1, 2, 2, 3, 3. In other words, a function inverse can be equal to the function, especially when it's the identity function y equal x. If you have another type, 1, 2, 3, 4, 5, 6, and you want the inverse for a discrete finite function, you just flip the coordinates, 2, 1, and so forth. So you will learn that there is a connection. The inverse function is a reflection with respect to the x-axis.